Hello everyone. The paper I'm going to talk about is called Time Travel Rephotography. So we only know historical people through some low quality black and white images. And these images were taken decades ago and they don't really capture how these people look like back then. So we would like to be able to convert these black and white images to images that look like they were taken with modern cameras and actually capture how these people look like back then. There are many data-driven works on colorization and super resolution. However, if you apply these works directly out of the box to this task, you will see that the outputs don't quite look like they were taken with modern cameras and they don't look convincing. Why is that? What is it about these old photos that make data-driven approaches a struggle? To answer this question, we have to take a look at some characteristics that these old photos have. One of the main properties of these photos is that the color sensitivity of the cameras and films that were used to capture these photos are different from those that we are used to today. Our modern cameras are sensitive to all three color channels. However, antique cameras and films were not sensitive to red color until the mid 20th century. As a result, they end up not capturing some of the features. For example, they don't capture a skin subsurface scattering, which has a smoothing effect on the face and mostly happens in the red channel. We can see this effect in this photo of Abraham Lincoln. We can see that his face in this photo has sharp features, and these features are likely exaggerated due to the film being only blue sensitive. One other important property of these old photos is that they typically have poor exposure and contrast. And if we want to achieve our rephotography goal, we should be able to somehow recover the missing dynamic range. And also, these images typically have low resolution and they are blurry. So we also have to take that into account into our problem formulation. So no wonder why these data-driven approaches are not suitable out of the box for this task. So if you take a powerful architecture which is pre-trained, such as Stalgan 2 architecture, and try to reconstruct these images, then you will end up also recovering the defects of these images, the qualities that we don't want, like low quality, poor exposure, and unnatural skin. So the first problem we talked about is color sensitivity. We can see that the way we convert our colored image to black and white has an effect on how that black and white image look like. So if we take our colored output and naively convert it to black and white image and compare it as the reconstruction loss to the input image, then we'll end up losing information in the red channel because we know the input lacks that information because the film and camera that was used to capture that photo was not likely sensitive to red color. So in this stage, we have to know the color sensitivity of the film that was used for that input photo and use that information to convert our colored image to black and white before comparing it to our input. We can know this information from the date that the input photo was taken in. And if we don't have access to that information, we can let the user decide the color sensitivity of that input. One other problem we talked about is poor exposure and contrast. Again, if we just take our output and naively compare it to our input for the reconstruction loss, we will end up recovering these poor exposure and contrast features. So to avoid that, we need to know the camera response curve parameters, but these parameters are unknown. The way we can handle this is that we can introduce these parameters into our neural network that we are training and learn these parameters alongside other parameters that we are learning in our neural network. Once we learn those parameters, we can use those to convert our output similar to our input before comparing them to avoid reconstructing those features. Also, for low resolution and blurry problem, we can apply Gaussian filter and downsampling procedures to our output before comparing it to our input. So this is the overall structure. The part that we are mainly interested in is this degradation simulation module. So our output, before being compared to our input for the reconstruction loss, goes through this module and we get a degraded output, which is actually a simulation of this output if it was taken with an antique camera. It does exactly what we've been talking about so far. So it applies Gaussian filter to make it blurry just like the input image. It considers the color sensitivity of the film that was used to take that input photo. It downsamples our output to be similar to the input, and it also has the parameters of our camera response curve. Once the output goes through this module, we can simply just compare it to our input for the reconstruction loss and backpropagate through our network. Here are some of the results of this work. You can see that the photos, the colored photos, actually look like they were taken with a modern camera. This work also has some limitations. For example, some very ancient hairstyle and beard styles that we are not used to today and our current pre-trained models are not used to are very hard to reconstruct. And if we have an input like that, we'll end up having weird features that are not desirable. That's it. Thank you so much for watching.